Trying to. Okay. So good morning, everyone. Starting with today's topic, how we managing multi VPC with peering and transit gateway. So these are like two important topics, especially the transit gateway part. So and also I would like to also I treat that the other previous classes are very important as well. I think as at now, I believe we should all be able to create a VPC and subnets, private route table, public route table, and all of that. I think that one should have been sorted by now. So the next stage, which is our level two now, is at the first item there is multi VPC management. And what VPC management, we'll be talking about two solutions there, PNN and AWS Transit Gateway. So there are two different items, but the other one is more very robust, very robust. And then also I treat as well that the next session after this is going to be how you can use Terraform to deploy everything we are going to do today. How I can just use some kind of a script infrastructure as a code to bring everything up and running. But today, we'll take us through the GUI parts and every other thing. So this is just about my page. So what I will be discussing today. So this is what we'll be discussing today. We're going to create three VPC, the private and public subnets, the security group, the private and public route table. We'll create peering, transit gateway. So I'll also simplify the explanation of attachment, route, and propagation in transit gateway. And also, how do you enforce isolation? How do you make, okay, I don't want A to reach B. I only want VPC A to reach VPC B, while VPC C cannot reach all of them. So those kind of isolation, that will be also done today. So that's why I said today's topic is a very long topic. So I just want you to follow me. And in any way you feel like it's getting more tough, just call my attention. Are we good to go?
Yes,
Are you
please.
hearing me?
Yes, we can hear you.
Okay, all right. So our previous classes, this is what we are working with. This is what we're working with. So this is the customer use case. Okay. This is iteration. Maybe the second iteration. Maybe we are very familiar with agile methodology of working. So this is second iteration, and they've assigned this task to you. Okay. You create a VPC. You're going to create an EC2 instance in each of the VPC for connectivity. And these are what we want to achieve. We want to ensure interconnection from web app VPC to backend VPC, and also from backend VPC to database VPC. So those are what we want to achieve. And also your implementation should be scalable, and as well it should be operational efficient. Please note those important parameters. Your implementation should be scalable and also should be operational efficient. And the last thing is that you need to draw an architecture of the whole setup, being the cloud network engineer. And so this is what is assigned to you for this week. Now let's get started. So the closest region to Europe, we can use London, which is EUS2. I think I've explained that in our previous session. We can use Ireland, which is EUS1. So for this implementation we're doing today, we'll be using Ireland, which is EUS1. So these are the VPC range. All of us understand how we get to this guy. Because we've already planned this guy earlier in our previous class. Okay, so web app VPC is 10.200. Database is 172.30, while the backend is 192.168. So these are the details we have today. So we can see the region. All of them are in the same region. Sorry, I think there's an error in that database VPC region. So another thing is that you can make it multi-region. There is no issue about it. Maybe you want to be US, why one needs to be. Maybe like the company is all over the world. So one is in Sydney, the other one is in Ireland, the other one is in US is one. So I explained in our last class that VPC is a regional service. So it doesn't matter the region you are, AWS still support it. So that's why I'm just trying to put that forward, that don't limit yourself. Okay, I'm putting everything in the same region. Just for the case of our classes, that's why I'm putting it in the same region. You can still have some classes that will do, maybe we will even do a kind of cross account sharing, maybe one account VPC, the other one is another account. So those kind of scenario, we're going to look at it all together. And as well, so these are subnet allocation. All of us agree to this guy. We've implemented this and everything is fine, right? Interesting. So this is how each VPC is going to look like. We have the public subnets, we have private subnets, and all of that. We all agree to that. So now let's come to our task of today. That's what we want to work on. We want VPC A based on this task here that was given to us. Web app VPC needs to connect to backend VPC. You know, I explained earlier that VPC is an isolated environment in your AWS cloud. It's just like your bungalow within an estate. So by default, each VPC cannot communicate to another by default. So you are the one as the cloud network engineer needs to now bring initiative. Are you connecting to each other via internet? Are you connecting via VPC peering? Or what are you connecting via? Maybe you're using, can you even use VPN, virtual private network? So are you at the network engineer now needs to bring that design? Okay, how do I connect my web app VPC to backend? Because the web app is the front end, needs to connect to the backend where the logic, the business logic is being done. So how do I ensure this communication? And we have two ways to do that, which brings us back to this place. So the first one is VPC peering. VPC peering is just is a way whereby please note it very well, two VPCs can communicate privately as if they are on the same network. So let's see that in your estates, maybe my own bungalow and your bungalow want to talk to each other, maybe wants to come and greet each other. So maybe instead of us now passing the main road going, so maybe there's a kind of an like a tunnel between those two bungalows. So that's how you see VPC peering is, from the word peering. So you can peer from VPC A to VPC B. I get me. So it comes with bidirectional from A to B, B to A. Do you understand? So now, what are the features of this guy? It allows private communication. So your isolated VPC environment, so that's what we want to achieve today. Web app VPC will be able to communicate to backend VPC, while backend VPC will be able to communicate to database VPC. But something here is that this same guy, we can use it for cross accounts and cross region. Maybe you have a region in EUS1, I've explained that earlier, and you have another region in EUS2. So you actually wanted to like make them communicate together. So irrespective of the region or the accounts, as far as you have something we call a kind of a cross account sharing, so that will be implemented between two accounts. Transitive. Now let me explain transitive. Transitive means that you cannot use VPC peering as a transitive. Let me come again. For example, VPC A connect to VPC B. VPC B connect to VPC C. That doesn't mean that VPC A will automatically connect to VPC C. So which means that VPC peering is not transitive. You have to do the connection between both of them. So if A and B are communicating together, B and C also will be communicating together on their own side. While A and C, you need to create a peering for them in a different way. So that's why the VPC peering is manual, because you need to start creating those peering one after the other, which is going to, assuming you have like 100 VPC now count the number of peerings you'll be having. And the kind of a company where you have like 30 VPCs, I don't know how you want to manage that. That will be a very lot of work on you. But now let's start from the simple part, which is VPC Peering, before we go to the advanced stage. Another thing is that you cannot overlap CIDR blocks. The CIDR blocks, what we explained before, like our CIDR range for each of the VPC, you can't have overlap. Yeah, like maybe you're having the same, let's say this guy now, this guy, you now have the same subnet range for both of them. It won't work. That's the law of VPC peering. So it doesn't allow overlap CIDR blocks. So let's continue. And also, the routing table, you need to manually update the routes in each of the route table. We're going to go to the practical. I'm just trying to take up through the fundamentals. So you need to manually go to your route table and start adding those routes one after the other using VPC peering. So it's manual, it's not transitive, and you cannot allow overlap CIDR blocks. So how does it work? Setting it up, you create a VPC peering from A will send to B will accept the request, and you update your route table. That's all. That's all. That's all. So we are going to get there. So let's start the implementation. So that reminds me. So let me know once you can see my screen. Can you see my AWS screen? I don't know if you can see my screen just straight. Yeah, awesome. So at this stage, I'm going to create the VPC now at this stage. So I know all of us understand how to create VPC. Because of time, I just want to ensure that the time we can really maximize it very well. So now let's create VPC. Now I want to delete my default VPC here. I think I'm in EUS 1. So let me delete the default one. I don't need it. Don't need the default one. Delete default VPC. This is a default VPC. You know, I told you initially that we need to like delete it sometimes. Yeah, somebody have a question? If you have a question, you can proceed.
Please, Mr. Suleiman, can you make the fonts a bit bigger? They are very tiny.
Okay. Thank you.
Thank you, sir.
Okay. Yeah. What about now? Is it better now?
Yes.
Yes, no.
Okay, all right. Thanks for that. So what we'll be doing now is we're creating 3 VPC now. I just want to take us through it very fast. I will have used Terraform to do this, but let me just use TUI. But we're going to be very fast because this is not what we want to achieve today. So because of time, so if there's a way you can't follow me, just let me know. But let's start creating the VPC one after the other. So let's start. Let's create. So what are we needing? We don't need NAT gateway. We don't need this guy. Let's create. Okay. That's the name. Let's create a web app of VPC. I think it's going to even put VPC at the back. So let's just put web app. So web app. What's the CIDR range? The CIDR range is 10.200.100.0/16. So we're not using IPv6. Tenancy is default. Our number of AZ is 2, right? And also public subnet to private subnet 2. We're not using internet gateway. We're not using VPC endpoints. So after the VPC peering, this endpoint is going to be our next class. So I'll explain for them. So now let's create this one fast. So I think we all get this right. I think we are done. So let's create the other one. Database web app backend VPC. Here's backend. So the backend subnet is 192. 168.0.0/16. I think all of us get all this right. So let us give them 2. The subnets, sorry, the subnets, don't worry about the subnets. None. I'll gateway none. Let's create. So it's something I want to point at later class, but I'll share it. As we have a lot covered today, so we have 2 VPC here. So let's create the last one. That's going to be database VPC, and I think database is 172.30, right? 172.30.0.0/16. There's none. So these are the ways I can create my VPC. I can as well use Terraform to do this. But we'll see that in the next class. So these are the 3 VPC now. Let's see your VPC. So these are the 3 VPC we have. We have the web app, we have the backend, and we have database VPC. And let's go to subnets. The subnets. So the subnet is not very well defined. Let's just delete it and create a new one. I'm not sure the subnet are defined very well. Route table is not. I'm not sure it has been created. Internet gateway. I think we have internet gateway already. Let me delete the default one. Let me detach it. Oh, what is this? I need the default one. So it's going to delete by itself and then just refresh. Yeah. So I'm just wondering why we have 4 VPC. So now let's this subnet. I'm not sure this guy was created very well. So now let's create. You can just delete these guys. Let's delete this guy because it doesn't create in the way that we want. So that's why I'm just trying to save time. Okay. And this was even the default one actually. So let's refresh. This is the default one. Interesting. So you can see. So because this guy was automatically created, so that's why we are having this kind of scenario. So I think the best thing we can do, we can continue with this, which is fine, or we continue with our own planning. So let's use our own planning. Let's use our planning and just take a little while, but at least you can just do it fast. Okay, so now let's create subnet. So let's start with web app. So web app, public subnet, public A. So let's use US1A. What we're looking is 10.200 docs. Based on our explanation, the third octet needs to be I think is odd, right? So let's use 1.0/24. This is based on our design. I'm not saying this is going to be like compulsory, like you have to do this report. Based on the design we did. So that's why I'm just trying to just follow along. I would have said I should just use the one that was automatically created when we create this guy, but I think just to conform with what we have. 10.200.3.0/24 about VPC. So let's create a new subnet again. Okay, we cannot create again. We cannot because it's a different VPC. So now let's remove this guy. So I think we are done with okay, we need to create the private. I think that's one of the reasons why I personally like Terraform. 10.200.2.0/24. Let's create this second one. Private B. 10.200. Dot 40/24. Okay. Can everyone, do you all understand what I'm doing? Is it clear? Are we still along? Yeah, interesting. I expected that you guys will be doing it on your side, one after the other. So this is web app. So let's create the one for backend. Backend VPC. So let's backend public A. So that's, I'm still iterating again. This is the advantage of Terraform. You can't run away from it. You can't. 192.168.1.0/24. And add the second one. I would have said I should just create one, but I mean, let's all be together with what we've planned. 192.168.0/24. Let's create the private subnets. Private A. This 192.168.2.0/24. The last one. This is just a preamble because it's just creating the base infrastructure, and it's good that we all take it through together so that we all be on the same page for the 0/24. So let's go through them all together. We're good. 168. I hope there's no mistake. 1681. This one is 168.30. So we're good. Let's create the subnets. And let's create the last one, which is the database. Database, let's see. So database. Public. So for our database, we don't need to be on public. We only need to be on private. But I'm thinking of how do we get it. So now let's do something. Let's just put private only for database. Private 172.80.2.0/24. Because we're using the database, so let's just put the private socket there. Okay, we're good. So what we did now is we create a VPC. We create 4 subnets for the web app and the backend, where we create those private access for the other one for the database. So you can filter your subnets with your VPC and all of that. You can okay, which VPC, maybe the first one. This is for the web app. You have it here and all of that. So let's come to the route table. So the route table. So I'm seeing a lot of route table here. So let's modify some things. I think just have one. Let's delete everything. Let's delete everything. the reason why I'm doing this was because when I was creating this, I just created it with more. I should have used big VPC on the why we start all this after the other, but just to make things clear. And that's why I'm doing all this. So let's so these are the default route table, like default ones for each of the VPC. So we might be using this guy and we might not use it. So now depends on us. So this is the default one for this is the web app, this database, and this is the backend. So for the web app, let's edit it and call it web app, web app public routing. So this one is backend. Backend. See why this one? We are not using for this for the database. We don't have public subnets. We have private subnets. So just private routing. So now let's take the association. So let's associate to this public routing. So let's put the public guys here. So the database as well. So it's association. Let's put associates guys. For the backend, so let's edit it as well. For the backend public guys here. So let's put a new subnet for a new route table for web app. Web app private routing. Web app VPC. The last one is backend routes private routing. So we choose the backend VPC. So where it's the subnet association. So the private routing is save. So let's check whether our private routing is also. Yeah, we're good. So at this point, I think all of us understand to this point, right? If you understand, I want reactions. If you don't understand, let me know. John, this is just like a song of what we did last week. It's only John I'm seeing his answer. What about others? Gabriel, please let me come on. If you don't understand, let me know. I can just come back. So what we tried to do was to create a VPC. After creating a VPC, we create subnets. We create subnets and we create route tables. And we associate the subnets to the VPC, to the route table. So all we have here is a public route table. We have the private and we have the backend. So on the public route table, so what we need to do is we need to edit the routes, as we said last week, like the default route goes through the internet gateway. So that will help you to call internet services from your VPC. This is the internet gateway. So we'll put it on each of the public route tables so that we can be able to reach any resources inside our VPC from the internet. You get? So for public, so the web app and the backend route public route table. That's where we put the default route pointing to the internet gateway. So good. Now we can communicate to the internet. But before we go to the internet, now let's create security group. So what do we want to achieve? Now let's create a security group now. So with what we've done now, we can access any resources created on the web app public subnet, and also any resources created on the backend public cloud or public subnet. So those are the things we've done now by putting the public cloud table, the public cloud table with the internet gateway for the default routes. So now let's come to the default security group. So I explained that security group works per VPC. So let's create one. Let's call it SSH remote. Let's call it jump or SSH remote. SSH access. Let's call it jump. SSH access SG. So allow SSH remote internet. I get in. So let's get it for the web app with security group SSH anyway because it's public facing to the internet. Or let's call it we call it SSH remote. No problem. We can just call it let's do it like that. Let's do it like that. It's fine. So one thing I want you to see is you can see that this guy associated to a VPC. So security groups are majorly associated with VPC. Let me click the other one. Hi, Gabriel, you have your hands up.
Yes, I have a question. You said security group are associated with VPC. So I was kind of confused. I need clarity because I thought it was a security group is associated with EC2 instance and network ACL to subnets. So I need clarity on that.
Okay, thank you. So this is what I'm saying, that if you want to create it, if you want to create a security group, it needs to be under a domain of a VPC. It must be associated to a particular VPC. What I'm saying is that if you create a security group in VPC A, it doesn't automatically work in VPC B. I get my point. So it needs to be under a particular VPC, like it's dependent to a specific VPC. So that's why I said it's associated to a VPC. So when you want to utilize it, that's when you associate with instance. When you want to utilize it, okay, maybe when you want to attach it to an instance. So because it's the institute instance that's going to inherit that security group. But when you are creating it, you need to put it under a particular VPC. I don't know if I explained it very well.
Okay, yeah, I get that now. Thank you.
Okay. Hey, what happens? How are you showing here before? It's fine. So now we are good. So we did our VPC. SSH, this one is related to the web app VPC, why this one is for the backend VPC. Don't mind my description. It's a bit different. But I know you all get this. So let's get started. So let's create an institute instance. So let's launch one. So what we actually want to implement is we want to see the VPC Peering, how it works. So let's call it test server web app server. We just call it web app server. It's not web app like that, so I'm not putting anything there for now. That reminds me that after level 2 as well, we'll be doing a capstone project that will be like an end to end. That will take a lot of because I don't want us to do capstone now because we've not really covered a lot of things. So when we reach application load balancer and all of that, so we can now do like a web a 3D architecture that will comprise of what we've done so far, something like capstone projects, hosting the website using S3 and all sorts of that. So I also have it in the pipeline in our consequent classes. So create we all know how to create a KPI. So then in the subnet, now let's edit the subnet. It's a web app VPC, right? We're putting it in the public subnet so that we'll be able to reach it from outside. So we select an existing group. Can you see? You will see it there. There's a switch guy. And we are good. Web apps server. So let's launch. We've launched it. So while this one is creating, can just do another one in the backend VPC as well. Let's create a new one for the backend. Backend server. And network is a bit slow using my side. It's always a bit slow. Backend server, let's use Ubuntu. The AMI 24 is fine. 2 micro is fine. Can use the same KPI. It's slow. So in network settings, we need to edit it. We need to edit it in the public. So the subnet, we've changed it. This one is we are putting this one in backend VPC. And backend VPC in public subnet because we want to reach it from the outside, from the internet. Enable. So select the security group. We've all done this last week, so that's why I'm a little bit fast about it. I think we all get what I'm trying to point. So the security group for now is just to allow SSH from the internet. So the main work now is let's log into each of them and let's see what's going to happen. And just refresh. So we have the two this thing coming up. So we have the backend and we have web app. So I think okay. When I was creating this guy, I did not assign a public IP. So that's why it doesn't have a public IP. Let's see what we can do here. Let's see. Okay, I can do it in a way. Let me just try and do something. Statement. Just let me just allocate an IP. I got create this for this guy. So what I did now is when I was creating EC2 instance, I did not associate and the public IP to it. So that's why I had to just create an elastic IP. This elastic IP is just a pool of public IPs from AWS. So I can use that static public IP and statically attach it to the EC2 instance. So instead of, and what's the advantage of this guy is that in case my my EC2 instance, I turn it off or anything, if I turn it on back using elastic IP, it's still going to maintain that public IP. But if I use auto assign, once I shut it down or I stop it or something, it's going, AWS is going to keep a new pool of public IP. So that's the difference between using an elastic IP to your instance or using the auto sign public IP when you are creating the instance. So, but in a situation where you are creating a web server, that the public IP needs to be statically configured. So this is what you need to do. You need to create an elastic IP and associate it to that EC2 instance. So we've done that. Now let's go to the EC2 instance and see what we have here. Okay, I think it's all good now. We have the public subnet and all of that. So let's see the public IP there. So from this private IP now, we can see that okay, this guy is a public subnet because of the third update here. So this guy is in the public subnet. Why this guy is also in the public subnet? Because of the third update is an odd number. I also have the public IP. So let me use putty to just take us through this guy. So putty. Let me copy the public IP for each of them. Let me copy the one for web app. With the public IP, I've copied it. And, okay. I don't know, my putty is not coming up. Why is it not coming up? So we have a lot of agents we can use. I can use it directly from my VS Code. For my VS Code to just SSH remote, or I use putty, or I use any services that works for me. Since putty is not coming up, let me use bash. Okay. Can you all see my putty session?
No.
Let me know if you can see my putty. Okay, you can see it. Oh. Okay. So can you see my screen now? What are you seeing now? Are you seeing my screen? Are you seeing putty?
Seeing your text.
Do you see putty? Or you're not seeing the putty section? Can you see the putty section now? Okay, so this is how you use putty to log in when you have a pen file. So you download your PSK, you download it as a PPK file because Putty actually works with PPK, private key. So you go to SSH here. This is just once Putty login, and you come to authentication, and you come to credentials, and the person and someone so you come to private key, and you load your private key. So once you load your private key, you open. I cannot even open it yet. You come to log the session. So the public IP I copied, paste it. Let me just save. Let me save. Let me save the session. So let's. Let me just test. Save. Can someone mute? I think the background. So for every Ubuntu server on AWS is every server on AWS is actually Ubuntu for Amazon AMI images. So for Ubuntu is username. For Linux or Red Hat or all of that, the username is ec2-user. So you can see I'm in now. I can log in. So I'm logged into the web app server. So it is up and running. So let's log in to the other one, which is on the back end. So let me copy the public IP. It's the same key I used as well. So Ubuntu. Can do this from different time. I just feel like I should use Putin. So yeah, good. So these are the 22 instance now. So what we have done now is that we've created two servers, one on the web app and the other one on the backend. But ideally now we need to now speak to two things. Number one, the EC2 instance, the connectivity. So we need to look into the security group, and also we need to look into the peering. Now let's do the peering first. But before we do the peering, I want us to see the effects of security group. So since I have the public IP, this is the public IP of the web app VPC. This is the public IP. You can see that I can't ping it. It is fine. I can't ping it. And what is causing this is because of the security group. And the security group, I only have SSH. I didn't allow ICMP or ping. So that's why I can't reach it on public IP. I get my point. So now let's do something different. Let me go to my let me go to my EC2 instance and let me go to my EC2 instance and okay. Let me go to my EC2 instance and come to my security group. So for the first one, which is the web app, let me edit it. The inbound rules. Let me edit the inbound rules. And let me add a rule. Let's say ping. It should be a ping here or ICMP. ICMP is also ping, so you can. Is there ping here? There's no ping. Well, ICMP is ping actually. So ICMP IPv4, that's where pings comes from. So let's see from anywhere. Let's save the rule. So we can go to the second one as well. Okay. I think my laptop is about to die. So we need, that's where you see the security group, the influence of security group. So the two security group for these guys, let me just update them and put ping. ICMP is actually ping. ICMP for custom anyway. So now let's save the rules. Okay, let's go back to these guys. So this is the public IP for backend server. We have it already. So let's copy the public IP for web app server. So let's then come here. So you can see that the ping is going up. So this is from the web app. I can actually ping the backend VPC, but I can only ping it on the public link. So why am I going to the internet before I can read something already on AWS? This is the you can see that we are on the web app VPC that 200, and let's check this other guy. So you can see the ping are going, which is fine. That's fine. But the ping is going via the internet. But we don't want that one to happen. We actually want to ping them using their private IP. How do you get their private IP? IP ADDR. You can get it from AWS as well, and you can also get it just with your Linux command. So this is the private IP of this guy. This 192.168.10.218, and the other one here, IP ADDR is 10.200.1.240. So if I said let me ping 192.168.1.218, which is this one, the ping will not go. And if I said from this backend, let me ping 10.200.1.240, you see it's not reachable. Why is it not reachable? Because the VPC by default cannot communicate. The reason why they can communicate before was because of the internet gateway, because you are pinging them through the internet. But if you want to talk to them via the private IP, the private communication, it cannot be reachable. We need to now start looking into the VPC peering parts. Am I communicating? So if you understand it to this part, please, I want reactions before we proceed. Okay, so we are good. We can see that now these guys cannot communicate via the private endpoint. They can only communicate via the internet. And before they can even communicate, you need to, via the public endpoint, you need to update your security group, which we explained last week, that security group work on the instance level. So you need to include that particular protocol. They need to communicate on your security group, which shows that these guys are okay and fine via the public internet. But via the private IP, they are not reachable. So now let's cancel this ping. Let's stop it. You can see that 92 packets are transmitted and we are not getting anything. That's fine. Now let's go to the real deal. Let me just minimize these guys and minimize this guy. So now let's come to networking. You come here, search for VPC. So once you get VPC, the next thing, calm down. There are a lot of options here in the VPC. You can see VPC peering connections. You can click it from here, or you come to this site. It's also somewhere around here as well. VPC peering also somewhere around here, but this is VPC peering connection. So you can click it from here, or you click it from here. Anyone is fine. So now let's start VPC peering. So we want to peer from VPC, a web app VPC to backend VPC. And I said that it must not have an overlapping CIDR IP address block. It is not transitive, and you need to manually update the route. You need to manually update the route. Now let's go on. So let's say peering peer from web app to backend, right? So who is the local guy? The first guy. Let's say the web app is the guy is initializing it. Now this is what I'm saying about the cross accounts. Maybe I want to request it to another account, not my AWS account. So I'm going to provide my account ID, the region, and all of that. So this shows that this guy can work with a cross account and cross region, maybe from EUS 1 to EUS 2, from EUS 3 to Africa AF. This is the South Africa AF Southeast 1. So any of this work. So where am I peering to? I'm peering to my accounts, right? I'm also peering to my region. This VPC is also in my region. Assuming it's another region, I'll just click on the another region here. You can see we have Asia Pacific, we have Sydney, we have Middle East, we have Israel, we have all of that. So it's just as straightforward as it is. So I'm still using the same region. That's where I have the backend VPC. So let me just click on the backend VPC. That's fine. And I create peering connection. That's all. So you can see that a VPC peering connection has been requested. So automatically it's going to send the request to you as an admin on your VPC. Okay, somebody has requested to peer with your VPC. And I'm still doing it in my own account and my own region. Automatically I'm going to see it. So let me come to my VPC peering connection. You can see this a VPC peering connection. We see actions, accept requests, because it's the same account and the same region. That's why I'm saying it right now. And you can see that pending acceptance. Assuming it's a different account, I'll need to log into that different account, go to the VPC, click on the peering connections, and I will accept. But you can see that this guy is pending acceptance. Let me just accept requests. These are the details. The same account, the same region, and all of that. The web and the backend. Are we getting it? Accept. So this shows that so now, I said something that this guy, you need to manually update your route table. We've created the VPC peering. That's fine. We are cool. But what's the next thing to do? So now let's go to the route table. Because we are only working on public route table now. This where our server is public route table. We might need to also include it in other route tables as well, so that all other guys in that VPC will be able to communicate as well. Because we don't really have a single route table for all of our subnets, so we have them based. We've already split them based on public and private and all of that. So that's why we might need to start manually updating the route. So let's go to public route table. What do you want to do? So we want to reach backend subnets. To edit it, you put backend subnet there, 192.168.0.0/16. That's the backend subnet. What are we using as our gateway to reach it? You just come down, peering connection. You'll see your peering connection from here. And you save changes. I get my point. So you do the same thing. We're doing it for the public route table. We do it for the private as well, because we want to ensure that all subnets in that VPC should be able to reach. You should be able to reach the backend VPC, which is 192.168.0.0/16. So you choose the gateway. You are using the peering connection. Click on it and save changes. Same thing. That's why I said this guy is a little bit manual. It's a little bit manual. So same thing. You go to the backend VPC, the route, the public and the private. you update the route as well. 10.200.0.0/16. That's our VPC cider block. Don't forget. The peering connection is the same peering connection. And you said. So let's go to the private as well. Backend private. Go to the route. You need to edit the route. You had it. This is the private subnet. So any server in this private subnet also should be able to reach you should be able to reach our web app VPC. So you put the cider range of what do you want to reach? Want to read the web app VPC from the backend. Put the peering connection and save changes. Are we clear? Is it are we getting it? Hope we are still on point. I think I will stop at this point. I want reactions. What's happening? Is it hard? Is it complex? Or are we getting it? It's only John that I'm seeing his reaction. So. Okay. I think all of us are still getting it. So if you feel like you have any questions, just let me know. I will try to come back and so we've actually done the VPC peering, and we can all get it. And so now let's come back to our testing. So now let's try to ping. So this is the 10.200 one is the web app server. We're trying to ping the backend server. So this is the IP. So if I ping now, can you see my ping is going right? So I can ping backend VPC from here. And the same thing, if I try to ping, I can ping web app VPC also from here. So instead of me going through the internet, I can just go through this VPC peering and it will be fine. So maybe you want to connect to the backend, maybe a Python application on port 8080 or port 5000 from your front end to your backend. You want to connect to any endpoint. Can easily, so the things you need to do is you update your security group and also you do your peering connection. So this is how peering works. This is how peering works. So most of the things you need to do is now the security group and your routing. You need to update your routing. So that's where the most of the work is. So this is the peering between this guy and the other guy. So we are true. So the next one is we can create, now let's do something. Database doesn't have access to the internet, right? So, and we want our backend to be able to reach database. So we need to create a VPC peering between the backend and the database. Are we communicating? So once we have that, we can then proceed. We can then proceed to telnet from the backend VPC to the, because these guys doesn't have access to the internet. So how do we reach our database? So we can then use the backend VPC to reach our database VPC because our database VPC is not exposed to the internet. So we cannot SSH remotely for the guy. So, or another thing to do is you can create a jump server in the database VPC, just create a jump server there. And from there, we can just try to access, but we don't want to have any public subnet on database VPC. That's the requirement. So now let's see how that works. So we've done the peering between this guy and the other guy. So now let's do the peering between the backend VPC and the database VPC. Now, follow me. So let's go to another. Let's go to the peering again. Let's create it. You know, I told you that the VPC peering is not transitive. So peer from peer backend VPC to peer backend to database. So who's the requesting guy? Backend. This is the requesting guy. Where is it going? Who is accepting it? The acceptance is database, right? So both of them are in my account. I've explained before, both of them are in my account. So assuming it's cross account, it's the same thing. You just put your account ID. It's very, very straightforward. But you can see a lot of manual process. I need to start updating the route table, all of that and all of that. So it's a bit manual, but it's very, very straightforward. So once I create the peering, I can just come to my peering connections. When I update it, you can see that it's already here. Once I can then click on it and actions, accept requests. So this shows that I've been able to pair my web app VPC to my backend VPC. And I've been able to pair my backend VPC to my database VPC. So I want to ask a question. Can web app VPC communicate to database VPC from what I just did now? I will just want yes or no. You can put your comment on the chat or you can even say it. Exactly. No, because there is no pairing. So this shows that VPC pairing is not transitive. It's not transitive at all. Because if you want it to communicate with database, you need to do the pair again. Because pair only works in bidirectional from A to B, B to A. Just between both of them, just like the guy is connecting both of them together. So we've been able to establish that we can only connect exactly one-to-one. I like that comment. One-to-one relationship. You and your guy, one-to-one. So there is no anybody attached to it. So now let's update the route. So so we come to backend route table, both the public and the private. So we need to edit it and we need to add the route. So we are adding the database subnet, which is 172.30.0.0/16. We're using the peering connection. So we're using peer backend to database. So we click on the guy and we save changes. So same thing, I think we use it for the public route table. Now let's do it for the private route table for backend as well. So we edit, same thing. So we're going to database 30.0.0.0/16. So we click the peering connection, and the peering connection is from backend to database. This is the guy. So we save changes. Now let's go to the database private route table. This guy. So don't let me do it yet. I don't want to do it yet. Should I do it? I just want you to see that. But okay, now let's do something. Let's create a server in database, and let's even see. Can we even ping it by default? Let me create it and let's see if we can ping it by default. So let me. So let's create a security group that we're going to attach to that instance. So let's call it database security SG. So ping and SSH access to database. So which VPC is it? Is it the database VPC? So yes, if the database wants to get update from the internet, so that's when we now create the NAT gateway. Same way I've explained before. So if, for example, okay, the database actually wants to get patch, we can then now create a NAT gateway and do the routing. So you can just we did in the last class. So we want a customized one. You actually only want to reach it from the database VPC, from the backend VPC. So 192, you can also say 16. So we actually want to access SSH database from our backend VPC only. And also we actually want to ping only as well from our backend VPC. So these are this is where you now start creating some kind of a kind of enforce isolation. Okay, on this database, I only want SSH to be allowed only from database VPC guys, and only database VPC guys should be able to ping. It's only backend guys that should be able to ping the database. So just check the rule SSH and ping, which is the ICM. So let's create and let's go to instance. Let's create a guy in the database subnet. So launch instance. So let me launch my instance. I'll see. So okay, database server. Let's use Ubuntu and all of that. Let's use this existing one. This is our existing KPI that we're using. So with network, we need to edit it. The guy is in the database VPC. It's using the private subnet. So the database guy doesn't have a public IP. It's going to have a private IP. So then we select our existing security group. I think that's all. Now let's launch. So once we finish launching this instance, let's see. So you can see you're going to get an IP. You can get this your private IP. So let's try to ping it from the backend VPC. Maybe the guy is still initializing, so it might not be very might not be up at the moment. So we're trying to ping. So we're trying to ping the database from the backend VPC, but you can see it's not going. Maybe let's wait for this guy to just finish initializing. And one of the reasons why it's not going is that we've not finished the peering. So the peering has not been completed. So that's why we need to come here. We need to come here and just create this guy. You need to come to the peering connection. So the peering connection has been active, but it's not updated our routes. So what we need to now check is, okay, let's check the public route table. I think we have it. Okay, we have the backend route here already. It's fine. So let's go to the database route table. But the route table for database has not had a route to the backend VPC. Doesn't have any route. So despite these guys, let's ensure this guy is up first and see that we are good. So the guy is up, but can we ping it? No, we can't still ping it. You can see that we can't still ping the database from the backend server. We can't still ping it, it's still not reachable. So let's just should we leave it? It's still not reachable. We can all see that we can't ping it because the peering has been done, but yet we've not updated the routes. So those are the challenges of physical peering connection. So if you are troubleshooting, those are the layers of troubleshooting you'll be checking. Okay, have you done the peering? Have you updated your route table? After updating the route table, And your security groups, do you have the right security group from the right subnets? So those are the things you need to check to start troubleshooting. So even if you are in an interview, you can even walk them through the solution. This is what we just did now, multi VPC management connection, so that they will understand, okay, this person actually knows what he or she is saying. So this is like a practical steps to troubleshoot. Okay, what's your first level? What are you going to check? What it is you're going to look at, and all of that. So with all these steps, so you'll be able to even convince people, okay, you actually know the stuff. You can work on this thing very, very well. So we can see that despite we created the connection, it's still not working, right? So now let's go to the route table of the database and update the route table. So any guy coming from backend VPC, which is 192.168.0.0/16. So we should use the VPC peering connection of what? We should use peer backend to database. And let's take this. So immediately I do this guy, the peering, I can ping. The ping is working fine. You can see that the ping is working fine. So this is how peering works. Either cross accounts, either multi-region, cross-region, or anyhow, this is how peering works. But this peering, it's going to take time. It's, we have to start updating the route manually, start doing a lot of things manually. So that's where our next class, because I think we already take a long time here. Our next class, we're going to go into transit gateway. But before we go to transit gateway, I have some things to explain. So you can see that we can ping. So now let's do another thing. You can see that I can ping. So which means that I've been able to establish connectivity from the backend VPC to my database VPC. Now let me cancel it. Let me just try to telnet to this guy on port 22. I'm just trying to confirm the SSH if SSH is working. If I can reach that guy on SSH ports, you can see that I can reach it. SSH open to something. So it means that from my backend VPC, I can reach my database VPC. So it's just a matter of me creating a jump server on my backend VPC, and I have my key, and I'm fine. I'll be able to remote SSH to the database VPC. So this is how VPC peering works. From the requester to the initiator, you need to update the routes, security groups, and all of that. So this is how VPC peering works. Now let me go back to my slide. So we've set up the VPC peering connection, and with what works now, you can see that I can still based on the request, web app VPC cannot reach the database VPC. So we've done that isolation already. We cannot reach it. But web app can reach backend, and backend can reach database. That's what we want to achieve, and we've already achieved that. So what is transit gateway? Transit gateway is just like a centralized hub. This guy is scalable, it's transitive, it supports multi-region, it propagates routes automatically. I don't need to start doing all these updating that I did in the earlier guy, in the peering guy. It updates its own connection automatically. And it's transitive. That's where what transit gateway comes from. Transitive. So it's scalable. It supports thousands of VPC connections. Not only VPC, it supports your VPN, maybe your on-premise network, maybe your direct connect, your dedicated 10 gig connection to AWS, or your VPC or your VPN, virtual private network. We're going to do that as well. So it supports any type of hybrid connectivity. This transit gateway is as far as you're a cloud network engineer, you need to understand it. Even as a cloud engineer, as an administrator, you need to understand transit gateway very well. So situations where we use transit gateway is that when you have more than 3 VPC, when you're having something like 10 VPC. And why do we need transit gateway? This is the bottleneck of VPC peering. VPC peering, you can only do a VPC peering of 125. So you can't do more than 125 per VPC. So you can only connect to 125 VPC peering. That's the maximum you can do as far as AWS is concerned. That's a bottleneck. For example, you have a company, you are all over the world. I've seen company with 200 VPC before. So those kind of companies, how are they going to manage it? And your static routes, I was updating those static routes manually. So those are the bottleneck that you personally will see that, okay, VPC peering cannot work for me. But in a situation whereby you just 2 VPC, 3 VPC, you can still use VPC peering. But when you are talking about scalability, your company is going to scale, and you are looking at future growth, you need to look into transit gateway. Another thing is that you can only have 50 static routes on your route table. That's the default. 50 static routes. So if I start having static routes updating per peering, at the end of the day, I can't do it for everything. And this is the formula: n into bracket n minus 1 over 2. So the n is the number of your VPC. Maybe you want to do like a full mesh. A full mesh means that you want all the VPC to connect to each other. So maybe you have 3 VPC now, and you want all of them to connect to each other. What is the total number of VPC you're going to do? 3 into bracket 3 minus 1 divided by 2. That's going to be 3 VPC peering. But on my slide here, assuming you have 10 VPC, and you want all of them to communicate together. So you'll be having something about 45 VPC peering. I'm very sure that's going to be tedious. You can't start clicking one by one. You can't. I can't even do that. I can't do that. So that's where transit gateway comes in. It's going to elevate this kind of manual process and bring in a kind of centralized routing in a transitive form. And it's very, very interesting. What transit gateway is going to do for us, maybe I should stop at this point today. So by next week, we're going to start transit gateway. So I don't want us to have much information overload, because transit gateway is also like a something on its own itself. So let me stop at this. So by next week, this same connection we did, we're going to try it again with transit gateway. We're going to do something more than this as well. So if you have any question, you want to ask questions, just let me know. I will be able to respond to that. Thank you very much. Hello, do you have any question? So, and as well, in summary, is the session very, very difficult? Because I've not had anyone talking or anything. Yes. I'm going to share the recording as well. Yes. Okay. All right. Thank you, guys. Thank you, everyone. It's good to have you today. So next week, we are going to start implementing transit gateway. How transit gateway works. This kind of scenario, how we can use transit gateway to do it very well, to utilize it very well, in the best position. And I'm very sure you're going to like transit gateway. So next class, the same time, same channel, same channel, same time. We'll see everyone by next week. So if you have any question, you can put it on the WhatsApp group. And as well, you can share these our previous videos, you can share it to colleagues or any friends you feel like they might have interest. You can watch it on the YouTube channel and all of that, and we'll try to grow the community. So thank you very much. In the absence of any question, I think I'm going to stop recording and going to call it a day.